Our team presents XDP Gait, a graded assessment and information tool for XDP patients. Let's take a look at the case of a newly diagnosed patient. Meet Jack. He's a 39-year-old man who recently got diagnosed with XDP. Soon, he is faced with the difficult task of determining the right pharmacotherapy to manage his symptoms. Physician-performed assessments are too time-consuming and subjective to be able to determine a response in 2 to 8 weeks. Due to this, his pharmacotherapy modifications are made primarily based on his own perceived symptom progression. After every formulation and dosage change, he is faced with the extremely subjective question of how he feels he is responding. Moreover, he faces the difficult task of traveling all the way from his village to the main city for every evaluation. As his disease progresses, his disability increases to the point that traveling to the city no longer becomes possible. To summarize the challenges based on Jack's case, evaluations for monitoring XDP symptoms are based on subjective opinions of the patient, caregivers, and the physician. This makes it difficult to reliably quantify the symptoms in a longitudinal manner. Disease-modifying drugs cannot be explored without frequent, objective, and precise measurements for clinical trials. There is also an added layer of challenge of geographic inaccessibility.
To solve these challenges, we propose XDP Gait, an automatic video assessment and grading tool which enables objective evaluation of XDP patients. Our solution comprises of 4 main components, which includes a mobile app that works offline for recording videos, algorithms for automatic graded assessment of patient symptoms from videos, a patient registry for storing longitudinal data, and finally, a web app for viewing the patient data. We will first look at how data can be collected from the patients. We propose to get help from the Sunshine Care Foundation's network of helpers who can use a mobile app to record videos while following the video protocol and assessment instructions displayed on the screen. To overcome the challenge of internet being inaccessible in remote regions of Philippines where the patients may be based, the app can be used offline. The recorded videos are encrypted and stored on the helper's device. When the helper is back to a region where internet is available, such as at a healthcare facility in the city, the app automatically uploads the video to a secure server for further processing. Once uploaded, the video on the device is deleted for added security. Our automatic assessment tool asynchronously analyzes the patient videos when it's available in the server. The assessment algorithms, which are built on top of existing position detection algorithms such as OpenPose, automatically quantify and grade the patient's symptoms by assessing the videos based on the historically validated UPDRS scale for Parkinsonism symptoms and the BFM scale for dystonia symptoms. For example, for the finger tapping test on the UPDRS scale, the tool leverages existing deep learning models that identify key points on the palm, and based on the relative movement of the key points, we calculate the number of finger taps and the average duration of each tap. At the end of the test, it also displays the tap frequency and the 90th percentile score, which captures the consistency of the average tap duration score. After the automatic assessment, the resulting scores, which include raw measurements as well as the scale-based grades, are stored in a patient registry, which is a secure storage that can only be accessed by the physician. The registry can serve as a data resource providing de-identified longitudinal data for XDP research and clinical trials. The web application acts as an interface for the physician to view the patient's data available in the patient registry. After logging in and entering the patient ID, the physician can view the patient data dashboard with scores for multiple evaluations conducted on the patient on different dates, as well as the patient's medication history. The physician can see the patient's measurements versus a normal person's measurements for each of these tests. They can also see the scores based on historically established scales such as UPDRS scale for Parkinsonism and the BFM scale for dystonia. On clicking the video button, the physician can see the actual video used for calculating the assessment score with annotations for different measurements. The web app also has a visualization dashboard with interactive graphing options that displays the longitudinal data for a patient pertaining to each assessment conducted on them. For each time point on the graph, the physician can also view the medication history of the patient, thus allowing the physician to see how the patient has responded to the medication and aid them in optimizing pharmacotherapy.
Our product thus solves all of the key challenges highlighted in Jack's case. It solves the challenge of geographic inaccessibility by utilizing video-based data collection methods, thus bridging the gap between the patient and the physician. The automated assessment of videos makes the evaluation more objective, precise, consistent, and reproducible, thus allowing more frequent assessments. In combination with the visualization tools, makes it easier to optimize pharmacotherapy. Our workflow also facilitates building of a centralized patient registry, which can further aid in clinical trials. In the short term, we plan to collaborate with Dr. Nitin Sharma, who is currently doing research on manual video assessments of XDP patients. We plan plan to use our automatic assessment tool to review and grade the already recorded videos, thus enabling us to fast-track the validation and improvement of our prototype. Over the long term, we plan to expand our toolset to automate up to 80% of the UPDRS and BFM scale assessments. Adding tests that are not covered under the current video protocols, like grip strength and rigidity, are also a part of future plans. Given our interdisciplinary backgrounds in healthcare and tech, we believe we are the best suited to bring the solution to the market and impact the life of XDP patients.